Welcome back. In the last lesson, you learned about common types of risks associated with the blockchain development. In this lesson, you are going to learn about the principles you should consider when designing a blockchain solution. For a quick reminder, a blockchain is a digital ledger of transactions that is duplicated and distributed across the entire network of computer systems on the blockchain. Decentralization, cryptographic security, transparency, and immutability are the four main benefits of blockchain technology. Without depending on a third-party authority, it enables the exchange of value and the verification of information. The technology can be set up in a variety of ways to satisfy the goals and practical needs of a certain use case, and hence, it doesn't have a single form. To design a blockchain solution that enables you to achieve and enjoy all the benefits of blockchain technology, there are 7 design principles you should follow. They are 1. Network integrity, which is concerned about the consensus mechanism your solution will employ. 2. Distribution of power, which is concerned about decentralization. 3. Incentivization, or offering value as an incentive, which is concerned about how you reward behaviors that are wanted in the system and discourage harmful ones. 4. Security of the system, which refers to your public key infrastructure. 5. Privacy, which refers to how you protect the data of your users in the system. 6. Preservation of rights, which refers to how everyone can benefit from the exchange of data in the system and still have their rights respected as individuals. And finally, 7. Inclusion, which refers to how you design your solution to include excluded and disadvantaged groups. Now let's take a look at each of these design principles and what they mean in practice. Network integrity refers to the trust that is coded into the blockchain solution. In a blockchain product, the trust does not come from an intermediary or an external source. Instead, honesty, consideration, and transparency are coded into each node of the software so that all the nodes in the network collaborate to ensure that the system agrees on an accurate record at any time. To achieve network integrity, you need to create processes that not only ensure transparency and fairness, but also make it unprofitable for cheaters to game the system. Most blockchain solutions adopt one of several consensus mechanisms to achieve network integrity. In lesson 1, we discussed the consensus mechanism known as the proof of work, which is the process by which a mining node guesses the correct nonce to create a valid hash for a block. There are other consensus mechanisms other blockchain solutions explore. They include proof of stake, proof of activity, proof of authority, proof of burn, proof of capacity, proof of contribution, proof of storage, and many more. Another popular consensus mechanism, which has been adopted by the Ethereum network, for example, is the proof of stake. The proof of stake protocols are a class of consensus mechanisms for blockchains that work by selecting validators in proportion to the quantity of holdings in their associated cryptocurrency. This is done to avoid the computational costs of proof of work schemes. The state currency acts as a collateral that can be destroyed if the validator behaves dishonestly or lazily. The validator is responsible for checking that new blocks propagated over the networks are valid and occasionally created and propagating new blocks themselves. We have discussed network integrity. Now we're going to discuss distribution of power, which is the second design principle of blockchain. Blockchain networks use a peer-to-peer network to share electricity. Multiple parties govern the system, which cannot be overthrown. The distribution protects the network from outside influences like the government while preventing a thief from engaging in extortion. It also defends a dissident in a totalitarian nation. Each activity and transaction is broadcast throughout the entire network for confirmation and verification. Nothing is controlled by any single entity. Novel distributed models of wealth generation could be made possible by a distributed platform. The most challenging socio-economic issues facing humanity today is the focus of cutting-edge peer-to-peer collaborations. The third design principle is incentivization, or offering value as an incentive. This simply means that the system is designed to reward behaviors that are beneficial and frustrate behaviors that are not. Offering value as an incentive also motivates participants in the network to contribute their quota to ensuring the success of the system. Participants in the network act in their own enlightened self-interest to ensure that they reap the benefits. When designing incentives, one must consider what users on the platform will find beneficial. If the users are not particularly interested in the incentive offered, it's not likely such an incentive will encourage participation. Incentives do not have to be financial in nature for them to be considered beneficial. Blockchain solutions may reward users whose actions align with the goal of the system or who have achieved a social status within the system as a result of their actions. This motivates participants to support the growth of the system. The fourth design principle is security. A blockchain network has inbuilt safety measures without any point of failure. They provide non-repudiation, authenticity, and anonymity for any action. This means that the veracity of documents, such as a digital signature, cannot be questioned. Anyone who wants to use the blockchain must understand cryptography. You can't opt out. Because of the way things are set up, any reckless behavior solely affects the person who committed it. A blockchain is virtually impossible to hack thanks to blockchain innovation on leveraging public key infrastructure from the beginning. To create a safe platform, Satoshi mandated that participants use public key infrastructure, or PKI. Users receive two keys in PKI. The two keys serve different purposes. One is used for decryption and the other is used for encryption. This kind of cryptography is called asymmetric cryptography. It was created in the 1970s and achieved popularity in the 1990s. You need to keep track of both of your keys as well as everyone else's public key. If you lose your password, you must start afresh because there is no password reset feature. An approach to this is to employ digital certificates. Users register for their individual certificates, which are pieces of code that protect messages without requiring an encryption or decryption procedures, and they pay an annual fee for them. Blockchain can offer motivation for PKI to be widely used for all value transfer transactions, effectively resolving all these problems. And lastly, as blockchains get longer, they get safer. Much more computing power is needed for a long chain hack than for a short chain hack. With a blockchain's transparent architecture and secure design, you can carry out valuable transactions and protect data. The fifth design principle is privacy. Data should be in the hands of the people who should even own it. People should have the freedom to choose which aspects of their identity they disclose with whom and under what circumstances. Central databases in the public and corporate sectors have gathered a variety of private data about people and organizations, often without such people and organizations' knowledge. Since you can't recall your past actions, words, or purchases from a year ago, your precise location, the medications you took, your diagnosis, your test results, or even your heart rate, these virtual data stores know more about you than you do. The issue is that since you don't own the virtual data or the virtual versions of yourself, this data can be sold to anyone without your consent. Anyone that has access to this information can deploy intelligence systems to make accurate predictions about you. In blockchain, no one has to provide personal data to conduct transactions. This is possible because the identification layer is separated from transaction layer. Also, since transactions take place between public keys, users can maintain anonymity on the network when conducting transactions. This way, users can protect their information and choose to give it at any time if they want and receive a compensation for it. The sixth principle is the preservation of rights. We all have certain unalienable rights when we are born. Rights are something we ought to defend. Ownership rights should be unambiguous and enforceable, and individual liberties ought to be respected and protected. As the internet became proliferant, copying and sharing of data became commonplace with little to no regard for the rights of the original source of data. Even when the laws governing copyright were adapted to meet the needs of the internet, intellectual properties of creators could not be completely protected from theft and illegal sharing. By making property rights unquestionable and unforgeable, blockchain innovation is enhancing property rights. A blockchain like Bitcoin, for example, timestamps transactions along with the proof of work necessary to create currencies. The only spend that will clear and settle is the first one. The blockchain's public key architecture not only stops double spending but also verifies who is the rightful owner for each coin in circulation. As a result, you cannot exchange items that are not yours on a blockchain. Real property intellectual property, or personal rights can also be treated this way. A smart contract that is stored on a blockchain can also be used to formally codify these rights and obligations. The required choices and incentives that will be made in a transparent manner and will have broad support. It should be noted that this issue transcends technology and extends far beyond physical assets, intellectual property, or any privacy tools. We need education along with deep understanding of rights management frameworks. Our seventh and final principle is inclusion, which means that you work actively to lower the barrier to entry so that more people can participate in your solution. In many parts of the world, the internet has not delivered prosperity to all, and lots of people are still economically disadvantaged. They cannot afford minimum fees and payments required to access services they need. Blockchain solutions should be designed to work with or without internet access, so that people who cannot afford access to the internet or people who have rather low bandwidth can still enjoy services provided. Designing for inclusion goes beyond making financial services accessible. It also means that people of all social and racial backgrounds are considered, and barriers based on health, gender, place of residence, or political preferences are removed. With that, we have come to the end of this lesson. In this lesson, we learned about 7 principles for designing blockchain solutions. These principles are network integrity, distribution of power, incentivization, security, privacy, preservation of rights, and inclusion. In the next lesson, we are going to learn about the different kinds of digital assets and specific use cases they satisfy.